Stream should be starting. There we go. All right, hey guys, welcome to day 2 of solving trig problems. I know that some of those problems got like kind of interesting in our last homework, so I did have a few people come and get help in office hours. Thank you guys so much for coming in and getting help. And I know, especially if you guys aren't super strong with your trigonometry, right? These can be really difficult, especially when we're going between, are we solving for an angle? Are we solving for a ratio, right? That can get confusing. So make sure if you guys have questions that you ask me questions in the chat, or that you turn on your mic and ask a question. And also make sure that you like and subscribe. I'm just joking about that last piece. I just feel like a YouTube personality. All right, so good morning, good morning. I hope you guys are doing well. I don't know about you guys, but outside my window, I see spotches of blue sky and the sun is coming out. So I am definitely going to have lunch on my deck. I don't care how cold it is. I need to get outside for a little bit. But what we're going to do today, it is a really short day. So if no one has any questions or concerns, then we'll just get right through the material and get you on with your day. Okay? So what we're going to take a look at. So last class, we started this idea of all these different tricks that we can use to solve trigonometric functions. So we're just going to take a look at some different skills today. And if you have questions, again, the chat or turn on your mic. Yeah. So let's do this. Let's do this jam. So the first type we're going to do is we're going to take a look at one that's a little bit like a quadratic. So we're going to find all solutions. Okay, and we're going to, what's our equation here? We're going to have 2 sine of x minus sine of x minus 1 equals 0. And one thing I notice is that people necessarily don't read the instructions. But I'm going to have an interval here from 0 to 2 pi. Now, remember with interval notations, what this is meaning is that it includes 0, but does not include 2 pi. Because remember, 0 and 2 pi, they overlap. And when they overlap like that, right, they would both be the same location on the circle. So we're including 0, but not 2 pi. I feel like I didn't write something down correctly here. Oh, there we go. There should be a squared there. Just looking at that kind of gave me the beebajibbies. All right, so how do we solve this? So again, there's always more than one way to solve. So I'm going to try to give you the way that not only is doable, but going to be something that you can use later on in life. So with this, in this case right here, there's 2 ways we can do this. We can solve, well, 3 ways. But the book tells you to graph it. Oh my God, never do that ever, because you're going to get an approximation. We don't want an approximation. We want exact answers. So stupid book. So I'm going to show you 2 ways to do this. One's going to be with substitution, and then the other one is going to be factoring. Okay. So the one I would recommend is substitution. It's a neat little trick that's really useful later on. So using substitution, does it really have that many I's? Am I spelling that right? Substitution. Yeah, I think it does. That's a weird word. Okay, so the first thing you have to do in substitution is identify what you're replacing. So in this case, I'm going to call sine of x. I'm going to call that, let's just call it theta. No, because we use that for angles. Let's call it y. Okay, so then I'm going to rewrite what I have. I have 2y squared minus y minus 1 equals 0. So if we do this, then it's really easy to do Pythagorean theorem. Okay, so my a here is 2, my b is -1, and my c is -1. Okay, so then it's just x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so That's why I like substitution. So this looks complex. And remember, we're humans, right? And I just had this conversation with my geometry students. Your brain likes to play games on you because your brain looks for patterns, right? So if it doesn't look like the pattern you've trained your brain for, then it's gonna appear to be harder. But if you change the way it looks, then your brain's gonna be like, oh man, this is a quadratic, so I can solve this, right? So that's really what substitution is about. It's about changing the way something looks so that you either are lazy and you don't have to write, like writing y is a lot quicker than writing sine x, right? So it could be for lazy, but it also could be to get your brain to see that pattern that you know how to do. Okay, so how are we going to do this? So always do the discriminant first, right? The discriminant is inside there. I happen to know negative 1 squared is 1. So it's 1 minus 4 times 2 times negative 1. So I get positive 9. So I get x equals 1 plus or minus square root of 9 over 2 times 2 is 4. Well, I happen to know the square root of 9 is 3, right? That's 3. So I get x equals 1 plus 3 over 4 and x equals 1 minus 3 over 4. So what are our answers? We get x equals, that's 4, so 1. And 1 minus 3 is negative 2, so this is negative 1/2. Okay. Oh, yeah, I was like, what? Like, what are we solving for? These aren't our answers, right? This is our answer for y. Oh, I should have done that. That was really stupid. I should have changed it for y. Because we didn't solve for x. X is what we were solving for. I'm solving it for y. I changed it in terms of y. So the part with substitution, and I almost forgot, you get all the way down here at the end, and if you're like me and you're tired and you're like, oh, I'm done, you know, I'm just happy, let's move on, you forget to substitute it back. So what does y equal? Y equals sine of x. So now I have to go sine of x equals 1 and sine of x equals negative 1/2, right? So we're replacing, we're going back there. So now we got to do this trig thing. So remember, in a trig function, the input is an angle. So what we're doing here is looking for an angle. And the more you do trig, the better you understand trig, the easier this is going to get. So we have sine of an angle equals an output. Now remember, sine is height. So some angle has a height of 1. Some angle has a height of negative 2. So we want to find what angles give us these heights. So if I take a look at a unit circle, we're going to look, when does sine have a height of 1? Well, sine has a height of 1. There's only one place sine has a height of 1, and that is x is going to equal pi over 2. Okay, that's the only time, if this is my Ferris wheel, that's the only time I'm at 1. Okay, so right here, x equals pi over 2. That one's done. Here, sine of x equals negative 1/2. Well, there's going to be two places that it's going to equal negative 1/2. Now, I don't have those places memorized. So what I do is I know at pi over 6, right, the coordinates here are root 3 over 2 and 1/2. So sine of pi over 6 is 1/2. So I'm just going to use symmetry, right? So this is going to be, you guys see how it's, I'm just down now, so it's going to be 1/2 down. And then I'm also going to use symmetry and be like, this point over here is also the same height. So these are going to be my two answers. So it's just a matter, right? So this is going to have a height of negative 1/2. So now it's just a matter of exploring and figuring, okay, what angle gives me those positions? So let's count these angles. So I got 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6, 7 pi over 6, 8, 9, 10, 11. right? And it's an odd number on top, so I'm not going to reduce it. So there's two places that we're going to have here. Now, we got to be really careful because we did plus or minus. So we were going to have to check. You would want to check to see if those, well, you'd want to check to make sure all three of these answers were correct. Okay? So here I can go like this. X equals 7 pi over 6 and 11 pi over 6. There we go. All right. So again, you would want to check all of those answers. So in this case, I got 3 answers. Okay? So now, again, this was quite the process, wasn't it? So started out, we substitute sine of x for y to make it something that's easier on the eyes, easier on the wrist to write. We used the quadratic formula. Then once we got down to what y is, we substituted back for sine of x and then used the unit circle to get our answers. Okay? So again, lots of small steps. And when you look at it, like if you zoom out and you look at it all together, it looks complicated, but it's just complicated in the sense that it's made up of a lot of really easy small steps. For a long time, I was a mountaineer, and one of the best advice I ever got was when doing something difficult was just keep your head down, look at your feet, and just take one step at a time, right? Well, that's if you're not leading. If you're leading, you better be looking ahead so you don't kill your group. But if you're following, all you got to do is just put your head down and you just keep walking, right? Just keep going. You're like the engine that could, right? I think I can, I think I can, I think I can. Choo choo. I'm tired and I've been talking to myself all day. So if I'm a little weird, it's because I am. All right, so that's one way of doing it. The other way of doing it, and I would say the more clever way of doing it, is factoring. Okay, and factoring is a more difficult skill to master, but it is infinitely more useful. Okay, and where people struggle in calculus on the calc exam is a lot of factoring. So I mean, it's not the only place. I'm like overhyping it, but it is a place where people struggle. So to do this, we talked about this last time. When doing this, what I like to do, so we're going to factor this, is identify your variable. So my variable is sine x. And then I always like to throw my a term into the first one. So I'm going to try to give myself lots of space. So I throw my a term in here, and then I have this. Okay. Now remember, when I multiply these together, I want to get this, right? So one thing, it's the middle term. Now, if you guys haven't learned the pattern for this, I would ask you to Google Pascal's triangle. Pascal's triangle, not a pastel triangle, because I'm not trying to push some trendy colors on you. Pascal. And Pascal's triangle basically is a pyramid of all the different factoring trees. And it turns out for a quadratic, that is for a term, it always is in the form of this. So that is okay, like that. And if we were in class, I would spend a good like 10 minutes talking about Pascal's triangle, but I don't have time. So we're not going to. So you can just Google Pascal's triangle. And Pascal is P-A-S-C-A-L. Pascal's triangle. Okay, and Pascal's triangle is about factoring and expanding. So basically, if you have something like this, it will always be in the form of this. Okay, now of course it's going to change with negatives and positives, but that's the general form. Okay, so Pascal's triangles is expansion of perfect squares. That's what it is. Okay, so if you can understand perfect squares, you can stand non-perfect squares. Okay, so basically what we're looking at, do you see how the middle term here, right, the negative sine x, is actually a combination of a and a b term. But it's easiest to find the a squared term, right? That's the front term. and it's easiest to find the b squared term. So as you can see, if I multiply these two, that's how I get 2 sine squared, right? That's my a. So I take the first term here and the first term here. That's how I get this term. So the last term, right, is going to be the last terms. So I know that whatever this term and this term is, it's going to multiply to -1. Well, that helps me out tremendously. What's the only way that I can get -1? It's got to be a 1 and a -1. So I'm going to have 1 positive. I'm going to have 1 negative. So then the next part of that is, notice how it's 2ab. So in this case, our a's are different. So basically, it's going to be this term, the first term times the second term, and then added to each other. So this times this plus this times this. So if we have 2 signs, so these are both going to be 1s, and this is 2 sign, I get negative. So that's going to be 2 plus sign, 2 plus 1. So how do I have a 2 and a 1 get to negative? This one's got to be negative, which means this has to be negative, because 2 sine of x times -1 would give me -2 sine of x, and then a positive 1 here would give me sine of x times +1. Now, again, if you guys don't understand quadratics, everything I just said didn't make any sense, right? Like, you're completely lost because you don't understand quadratics. So I would take some time. I would take a look at perfect squares to understand how non-perfect squares work. So again, the middle is, right, a times b plus b times a. So you take this one, and then you add it to this one. Now, this one says 2ab because they're the same in a perfect square. But if it's not perfect, it's just saying you take this plus this. That's how you get the middle term. And then to get the last term, you just take the second terms of each and multiply them. Okay? So that's how you tie it all together. I hope that was helpful. But this is the superior way to solving, because right here, then I'm going to use zero product property, ZPP, and I'm going to say, okay, 2 sine of x plus 1 equals 0, and then I have sine of x minus 1 equals 0. So if I solve these, I get sine of x equals -1/2, and sine of x equals 1. Now, if this looks familiar, that's because all the way down here, we got the same thing. Look how much we cut out. Do you guys see how much we cut out? So factoring is superior. Now, it's only superior if you can get quick at doing this, right? And the only way to get quick at doing it is practice, practice, practice. Gosh, I am boring myself. Like, I am just talking. Oh my gosh, Kraft. I just want to fall asleep. This is the most boring class ever. All right. So then I would solve this. So again, do the unit circle. There's only one place sine equals 1. That's pi over 2. I know here, I use that. So this is my answer. This is my answer. So I get x equals 7 pi over 6. And 11 pi over 6. Notice up here at the top that we're on an interval, so that's it. Those are the answers. Okay, so again, I'm presenting 2 ways of doing this. Notice how one way was significantly shorter. Okay, both are valid. Both are valid. Are you guys alive? Is my internet still working? Are you guys actually receiving this? Oh, thank you. I appreciate you. Oh, thank you guys. I'm alive. Good. Some of you are coming back from being dead. That's wonderful. You know what's really sad? The amount of people who responded back yes in some form was the most communication I've had from students all day, and you guys are my 3rd class. I'm alive but dead. Ooh, zombie action going on. Now, really important, are you like a rage zombie so you're quick, or are you like a dead zombie and you're really slow? Because, like, rage zombies scare me. I can't handle that. Too fast. Okay, all right. All right. Hey, we only got 2 more to do. So let's do another one. Unless you guys have questions. But you guys know me. I don't care about your questions. Okay? Yeah, I could be a zombie. Nah. Actually, if you think about it, think about math teachers for a second. See, it's a funny joke to think math teachers are like pirates because they're trying to get you to find x, to find their treasure. But don't you guys think that after a math class it feels like your brain is dead and like it's like melting out of your ear? What if I was a zombie and I knew the only way for me to get your brains is to melt your brain with math and have it ooze out of your ears, and on the way out I just take my finger and go. Okay. I was uncomfortable with what I just did, so it was kind of creepy. So let's just move on and pretend. Write a book. With all my free time, I will write a book. All right, so next one. Let's do 2 sine squared of x plus 3 cosine of x minus 3 equals 0. Okay. Now, again, we're just doing more of these. Am I supposed to feel that way? No, it's just a joke. I'm just joking because students always like, oh, my brain hurts so much. Math hurts me. It's a common complaint. Yeah. What doesn't kill you makes you stronger? I don't know. All right. So what's wrong here, guys? We have a sine. We have a cosine. To do this, I need them together. Okay? So the trick here, does anybody remember the trick? The trick here is you look for squares. And the reason for that is because it's really easy to convert squared terms. Okay? Because it's easy as A, B, C. 1, 2, 3, A, B, C. I don't know the song, but the Jackson 5, right? So sine squared plus cosine squared x equals 1, right? It's just Pythagorean theorem. Nice try. Thank you. I mean, if you don't try, then how do you know that you're bad? Hey, you're the only students that talk to me, so whose fault is it? I have to, this is my job. I literally do this. All right, so what we're going to do is solve for sine squared. So I get sine squared x equals 1 minus cosine squared x. So what I'm going to do is I'm going to take this, and anywhere I see a sine squared, I'm going to plug that in. So I'm going to get 2 times the quantity of 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. I mean, what I could do is I could just not talk and just do math, and you guys could watch me. I mean, I could make this really boring. All right, so now, why is this good? This is good now because it's all in terms of cosine. Don't do that. I could also talk in monotone and teach like this. So as you can see, I have this equation in all cosine. Distribute engaged. Frustrating, right? And that's why I'm here, guys. It is frustrating, and it's just a matter of knowing tricks, and it's a matter of doing that. Talk with an accent. Hey, oi, hey, little laddies and lasses. No, I'm not doing that. All right, let's see what we get. 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Let's combine like terms. So I got a 2 and a negative 3, so I got negative 2 cosine squared x plus 3 cosine x, and then negative 1 equals 0. So I just combine the 2 and the negative 3 to get 1. Oh my gosh. Oh gee golly, guys. Don't you know? Okay, so now I don't know about you, but I hate negatives with my A term. So I'm just going to multiply everything by negative 1. And I hope you guys realize there's a lot that you can do in math that your teachers never told you can't do, but no one ever told you can't do it. So we're going to have 2 cosine squared x plus 3 cosine x. That was a lie. Minus 3 cosine x plus 1 equals 0. I need to take a nap. I need some coffee. All right. So I'm going to solve this by factoring because I'm going to. So if I solve this by factoring, I would go 2 cosine x and then I put a cosine of x here. So again, for these last numbers, I know they're going to multiply to get this. So I get a positive 1. So that means either I can do positive 1, or negative 1, negative 1. So let's take a look at here. I have 2 cosine and I have cosine, and I want to get to negative 3 cosine. So the only way to do that is both of these are negative. Right? And you can kind of think of it as guess and check here, right? You're just kind of guessing and checking until you get it right. So check this out. 2 cosine x times cosine x is 2 cosine squared. Negative 1 times negative 1 is 1. 2 cosine x times negative 1 is negative 2 cosine x. Negative 1 times cosine is negative cosine. That's negative 3. Okay? So then I can say, hey, 2 cosine of x minus 1 equals 0. And cosine of x minus 1 equals 0. And then speed solve this equals 1/2. Speed solve this equals 1. And then I win. Game over because I just got, oh wait, uno. You win after you, okay, never mind. The circle of life, and it keeps us moving. So when does cosine of x equal 1? There's only one point that happens. Now, did I put a thing on this? I sure didn't. So we're going to have to do general solutions. So this happens at 0. It happens at 2 pi. So I would go x equals 0 plus n2 pi, or just x equals n2 pi. Are we doing okay? Did I just drop some like serious truth math bombs and you guys are like trying to catch up? I'm waiting, sorry. Does this make sense, guys, what I did? Are you okay with the factoring? So why is what? Okay, so x equals 1. So cosine, remember, is left to right. So when is cosine furthest to the right? Cosine is to the right one right here. So that's either 0 or 2 pi. So there was no domain restriction on this problem, so we're finding general solutions. So I would write 0 plus any rotation, right? So if I was at 0 and I rotated once, same answer. Or I could go negative, same answer. So instead of writing 0 plus n2 pi, because 0 is nothing, this is the same thing, and you don't have to write as much. Does that help out? All right, this one, on the other hand, we're going to have to find when cosine is to the right 1/2. Well, I happen to know that cosine is to the right at 1/2 at pi over 3. Okay, or pi and 1/3. So cosine to the right, so if we do symmetry, that's also down here. So let's count. So this is pi over 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be 10 pi over 6, which is 5 pi over 3. So I'd have two answers, pi over 3 and 5 pi over 3. I mean, technically we could say negative pi over 3 too, right? But we don't usually like negative answers. Okay, so what angles am I to the right 1/2? Well, there's two places where I can be to the right 1/2. Pi over 3 and 5 pi over 3. So I get x equals pi over 3 and 5 pi over 3. Oh, I didn't add the general. So it would be x equals pi over 3 plus n2 pi, and x equals 5 pi over 3 plus n2 pi. So these would be my answers. When I get tired, sometimes I forget that I go fast, or that I'm capable of going fast. Are we doing okay? When you type S with a backslash, it looks like you're searching for a directory. All right, one more problem to do, and then we can all go to bed. All right. What day is today? Today's the 14th. What are we doing? Okay. Whoa. Oh no! Guys, I did the wrong thing! Are you joking? Guys, we did this lesson last time! Oh my gosh, I'm so tired. Are you guys joking me? Okay, really quickly, law of sines. We literally are doing the same problems we did last time. I am so angry at everybody. That's okay. Your homework is really easy. Okay, this is law of sines. Okay. This is everything you need to know. So this is your lesson. This is your lesson in a short lesson. All the angles are capital letters. The sides are the lowercase letters opposite of the angles. Okay, we're going to spend 2 days on this. Okay, so guys, we're going to spend 2 days on this. All you're doing today is using law of sines to find missing angles. It's going to be really easy. Okay, law of sines is this. It is side A over sine of angle A is equal to side B over sine of B equals side C over sine of C. Only use 2 at once. Okay, we're out at 12:10, right? Oh, we're gonna be so good. No need to panic. So we got some review in. Are you guys feeling good? We got some review in, and we're gonna learn new stuff. So law of sines. Yeah, I'm really glad that we did it again too. So law of sines is this. It's a formula. Now, law of sines next class is gonna get real. It's gonna get real. So just I want to put this announcement out. I would suggest between now and next class that you read section 6.1 so that you're not overwhelmed next class. But this class, all you're going to do is you're going to use this to find missing pieces. Okay? So what do I mean by that? Oh, and one other thing, you still can use Pythagorean theorem. No, you can't. The other thing, another note. Angles in a triangle add up to 180 degrees. Okay, with these two things, you're going to get through your homework just fine. Okay, now we have law of sines, and we're going to do law of cosines after this. Law of sines allows us to solve. You remember solving right triangles? And solving right triangles meant find all the sides, find all the angles. You guys did that in geometry. You're like, crap, geometry was like so long ago. But you did that. You did that in geometry. You solved right triangles. You found all the missing sides, all the missing angles. Law of sines works for any triangle. So it's for any triangle, not just right triangles, okay? So let's do an example, and you're going to see how easy this is. Okay, I'm going to draw a picture. Now, the only hard part about this is if you don't, that's the only thing. The only time this is hard is it doesn't give you a picture. So here's what I suggest. Draw a picture. If it doesn't give you a picture, what do? You draw a picture. What do you do if it doesn't give you a picture? You draw a picture. Okay, that's it. All that matters, A doesn't have to be in the lower right. All that matters is that angle A is across from side A. All that matters is that's true for each one. Draw a picture. Thank you, Savannah. You rock. Okay, so let's go ahead and fill some stuff out. So let's say this is 28 feet. Let's say this is C, and let's say this is 102 degrees. Let's say this is A. Let's say this is capital A. Let's say this is capital B. And let's say this is C. We're going to solve the triangle. Okay, so we're going to find all the missing pieces. So let's take a look what's missing. We're going to find two angles. We're going to find two sides. Okay, we're going to use law of sines to do this. Okay, is that really all we have? No, one more piece of it. I was about to say, we're not going to get too far with this. So this right here is 29 degrees. Okay, so let me give you a tip. If you're ever given two angles, find the third angle. It's so easy. So you're given two angles, so I'm going to go ahead and find the third angle. So I know that angle A plus angle B plus angle C equals 180 degrees. So angle A plus angle B is 29 degrees, and angle C is 102 degrees. So I'm just going to go ahead and solve that really quickly. Angle A equals 49 degrees. Do you guys see how easy that was? It's like, yeah, geometry. Woo! Take me back, take me back. Guys, isn't this so much easier than what we were just doing? Oh, so maybe it was worth it. Yeah, love it, love it. Subscribe. Okay, so again, now you're not going to always be able to do this. This is only true if you're given two angles, right? If you're not given two angles, then you're going to have to keep going. So now, how do we find the rest? Okay, so, and maybe I want to write this in. So this is 49 degrees. Okay, okay, so let's say solve for A. So let's solve for side A. So what I'm going to do is I'm going to start with side A. So I'm going to say A is over sine of 49 degrees. And then I have to set that equal to another one. Well, I know B, don't I? So I know angle B and I know side B. So I guess so side B is 28, right? So this is B. And then angle B is 29 degrees. That's it, guys. Now, I'm going to warn you, the only thing you have to remember here, because we're going to get decimal heavy, you need to type this into your calculator all at once. You cannot round, you cannot round, you cannot round, you cannot round until the end. Do you understand? That wasn't a glitch in the internet. I literally said it that many times. You cannot round until the end. So to solve this, right, we would multiply both sides by 49 sine of 49 degrees. And we would go A equals 28 over sine of 29 degrees times sine of 49 degrees. And you just take a calculator and you type it in just like that. So I'm going to have 28 over, make sure, so like in my calculator, I don't know if you guys can see that. You have to make sure you're in degrees. Oh my gosh. Get out of radians. You should be in radians. I hate this book, but get into degrees. You guys have to be in degrees. So I'm going to go to mode and I'm going to go degrees. So you have to be in degrees, okay? Because this is in degrees. So I'm in degrees and I have sine of 29 and then I put parenthesis and then I do sine of 49 and I get A is, so I don't know what the book has you round to, but let's round to the hundredths place. So that's a 7. So this would be 43.59 feet. Boom. Okay, this is literally your homework. I hope you guys are super excited. Okay, and then the last piece, so I solved, so that was A. So the only thing I have left is C, right? So I'm gonna solve for C. So I'm just gonna set up another equation. So I'm gonna start with what I'm solving for. So C over sine of 102 degrees. So again, the side goes with the angle. And then I'm gonna pick another one. So I could pick A and I can pick B. Now, since A is a decimal that I rounded, do you guys see how I rounded A? I'm not gonna pick A because this is rounded. So if I use a rounded something and plug it in here, it's gonna be wrong. If you did use A, you would have to use this ugliness. So just don't use A, use B. So I'm gonna say 28 over sine of 29 degrees. Okay, I multiply both sides by sine of 102. Now, I don't know about you guys, but are you feeling like we're back to like algebra? Like, doesn't this feel good? You guys got this. Everyone's like, Kreft, where was this? This is it. The day just got better. Okay, and then you type this into a calculator. So what do I have? I have a fraction 28 over sine of 29 times sine of 102. So I get C, and I'm going to round to the second decimal place right now, so it's a 2 after that. So I'm going to get 56.49 feet. Boom, done with the problem. That is literally all you need to do. So the only trick, if they give you 2 angles, you can just do angle sum theorem that they add up to 180. That is epic. Do you guys have any questions? I can pump out another one of these. What a save. Isn't this an epic save? I saved this lesson. I totally meant to do this. I knew you guys needed review. Totally did this on purpose. It wasn't because I'm really tired and I need to sleep. I really thought today was the 11th. I thought the timer on the screen would help me out, but no, today's the 14th. Okay. All right, cool. So let's do another problem because no one else is saying anything. I don't know if you're in shock because what you just saw was so awesome. Okay. Okay. So we only have limited time, so I want to do one without a picture. Oh, I am so sorry. How long do you need to copy the answer? Are you done? You're good? And thank you for saying something because I hate it when teachers go too fast. I hate it because it's not about them. It's about you, right? It's about you're the one who's learning. You're the one who is going to go do great things, right? Like, who am I? I'm just a teacher that sits in a basement and talks to himself all day. All right, so what do you do if no picture? Okay. Ooh, excuse me. So, you guys tell me, What do you do if there's no picture? Do you freak out, melt down, and be like, well, I guess I'm playing Fortnite? Wendy knows what's up. She's like, Fortnite. I don't know what the Fortnite dances look like, but I imagine it's something like this. Okay, draw a picture. Thank you. So draw a picture. And for right now, it doesn't matter. Again, you want to read, guys, read section 6.1 before next class because it will get real. It's going to get very real next class. And then label it. It really doesn't matter how you label it. I'm going to be consistent with the book. Sorry, the book always calls that C. It doesn't matter. It really doesn't matter. Okay, now we're going to label things. So if this is angle B, this is going to be 15 feet. If this is angle A, that means this is going to be 24 feet. And angle A is 26 degrees. Okay? And then all of a sudden, we went to a problem that had no picture, and now it has a picture. And now we're going to solve it. So notice how we don't have two angles here. So we can't start off by finding another angle. Sad. Okay? But what we can do, so notice how I know angle A and side A, right? So I can go ahead and find, I don't know anything about C, so I can't find C. Do you guys see, right? And you could try to find C, but you're going to get stuck. But we can't find C because we don't know anything. But I do know a side of B. So what I'm going to do, and remember with fractions, you can flip them if it's a monomial on each side. So for example, I can write this like this. So I could write 15 feet over sine of B equals 24 feet over sine of 26. Okay, so I could write it like this. So again, right, these are both B, and this is both A, right? So that's what I'm doing there. Now, the problem with this is what I'm solving for is on the bottom. There's no need for me to write an equation where I have to do more work. So the simple solution, so don't do this, is just if you're solving for an angle, flip it. So just say sine of B over 15 equals sine of 26 over 24. I feel like I just created the Drake meme. You know, like, ooh, don't do this. Ah, do that, right? So don't create an equation where you have to do more work because the way you created it causes more work. Put what you're solving for on the top, okay? So then you would just go ahead and solve this like you normally would. So I would multiply both sides by 15. So I'm going to get sine of B equals sine of 26 degrees over 24 times 15. Notice how I'm not touching my calculator because, again, do not use your calculator until the very end. You need to type everything into your calculator all at once. Do not round end. Okay. And then how do I get B by itself? Do I buy a bottle of Coca-Cola and a couple of warm tacos and say, hey, how would you like to have lunch with me? No, you do sine inverse. Though it would be hard for me to say no to a Coca-Cola and some tacos. So I'd get B equals sine inverse of sine of 26 degrees over 24 times 15. And guys, at this point, all you gotta do is use a calculator. All right, sine inverse, and then fraction, sine of 26. And then remember, if you're not in degrees, you're not gonna get the right answer. I know I say that, but people are going to be emailing me saying that they're doing everything right, but their answer is wrong. You gotta be in degrees. So I check. I typed it in exactly, and Desmos Scientific Calculator will do all this for you guys. So I get angle B, and we have to remember it's an angle because we're going to have to add units to this, is 15.9, and if I'm going to the hundredths place, it's like that. So boom. Okay. Now, can I find angle C? Yeah, because to find angle C, I know angle A plus angle B plus angle C equals 180 degrees. Angle A is 26 degrees. Angle B is 15.90 degrees. And I don't know angle C. So if I solve, I take 180 minus 26 minus 15.9, and I get that angle C is very obtuse, 138.10 degrees. Oh my gosh, I hope you guys are pumped. Do you guys see how this is just a lot of arithmetic and calculators? Is anybody as pumped as I am? Oh, okay, so it's 12:10. I'm almost done. Sorry about this. So let's see here. So we have all the angles. So the only thing left we have is missing side. So let me find side C. So side C over angle C. So sine of 138.10. Do you guys see how rounding errors are going to get real here? And then I'm going to use A. So 24 over sine of 26. So I'm just going to use the one that was given. Okay, so I would multiply both sides by sine of 138.10. Sine of 138.10. So I get C equals 24 over sine of 26 times sine of 138.10. So I grab my calculator. I go fraction 24 over sine of 26 degrees times sine of 138.10 degrees. And I get C equals, and I'm in feet, so 36.56 feet. And there we go. I have answered 3. And for all of these questions on your homework, guys, you're going to be given 3 things, and you're going to find 3 things. Because remember, from geometry, triangles have 6 parts. So you're going to be given 3 parts, and you're going to find 3 parts. Hey, now, before you guys leave, there's something I want to make sure you guys are super clear on. There is no school on Monday. That's Martin Luther King Day. There is no school on Tuesday. That is a teacher conference day. And then Wednesday is another teacher conference day. So there's no school Wednesday. So you guys have a 5-day weekend. Yes, you did the math right. I will not see you for another week. So this is a great time if you're missing assignments to get missing work done. So on WebAssign, file for extensions, ask for extensions. Now, some of you are telling me that when you go to file an extension, you're getting like a fuzzy screen. Can you guys take a screenshot? Because it's only happening for some students and not other students. If you're on a computer, you can do the Windows key, Shift S, and that will be, you can do a capture screen. You can just drag a box to do that. But if you can email me a screenshot of that, please let me know. If it's not working, just write me an email and I'll get the extension for you. But we need to figure out why that's happening. So you have a week. You have a short assignment. I think this assignment is 1, 2, 3, 4, 5, only 6 problems long. I mean, it's really basic. Make sure you read 6.1 before next class because we're going to learn about ass triangles, and ass triangles are very much an ass problem. And so remember in geometry, your teacher was like, don't say the word ass. We can't do ASS triangles. Well, we're going to do ASS triangles, and we're going to say ass a lot. So be prepared to talk about ass triangles and solve ass triangles next class. So read section 6.1. Guys, I'm so sorry that I wasted your time.